Don't try to sneak into your room like that. I know what you've got behind your back. Records. More new records.
I'm David Stephen, Managing Director of dCS Audio.
I'm Emran Mangelson, North American Director for dCS.
For those of you that don't know me, I'm Chris from Innovative Audio. That's Elliot. We are obviously excited to have you all here. With David Stephen, Managing Director of dCS, and Emran Mangelson, North American
Director of North America.
Of everything.
Thank you very much.
Thank you, Chris.
Yeah, pleasure to be here. This is a fantastic store, and Chris and Elliot really try and get the best out of every product that they represent. So to come here and do it in this space with this system, it feels right. I remember coming here 12 years ago to New York to launch Vivaldi at the time, and for us that was the first project that myself, Andy and Chris had led at dCS. And people sometimes say that dCS is a family business. I've always seen it more as like, there's this amazing culture and technology and some really talented people, and you're trying to move it from one generation to the next. So Chris and Andy had taken over the company along with my father from the founders, Mike and Duncan, who were geniuses, and they kind of, they created technology in the early days primarily for radar and telecoms and recording in the A to D world. And then that legacy passed on to Andy and Chris, and from there we've tried to kind of drive the company forward and keep innovating and keep being state of the art. So for us it's about, can we be measurably and demonstrably superior to any other D to A technology. So when we were developing Vivaldi, it was about silver disc, right? So we were trying to get the most from those ones and zeros on CD and SACD. We could see that computer audio was kind of coming along, so we had the foresight to put a USB and a network input on that stack, and then it's just transformed. So when I look at where we are now as a company and as a platform to what Vivaldi was, it's a radical difference. So Vivaldi is still state of the art. It's still a product that we are really proud of. That's been in the market since 2012. It's been through numerous software updates and hardware upgrades, and for us I think that's really powerful, because this can be an expensive hobby for people. So we want to get the most out of our platform, and we want our customers to get the most out of their investment in dCS as a product and as a company. So Vivaldi has gone through, we're on to, we updated the software to 2.0, which increased the speed at which the ring ran. We've updated the DAC board to Apex. We've improved the network stack and switched out the network cards. So there's been a huge amount of innovation gone into that system to get it to where it is today. But about 5-6 years ago, we kind of sat down as a team and really started with the musical experience. What do we want here? We want it to be more lifelike. We want it to be more emotional. We want to connect people with the music, and we want to get more information out of that recording. And when you start with it being experiential, it's like, right, what does that mean in terms of design? Well, we have to look at industrial design. We have to look at user interface and how people control the system and access music. But then you also have to look at your own technology, and it started with the DACS. So, the mono DAC idea is something we'd kicked around for a long time, and the hardware team thought that they could do it, but then we get into some challenges which Andrew and Emma will talk about later. And if you've got a left DAC and a right DAC, how do you keep them in perfect sync? So then we spent a lot of time looking at Ravenna and AS67 and Dante, and we realised that actually we think we could do it our way and do it differently, but in a way that would let us use the local oscillators and the DAC. So that started to grow arms and legs. So I've been trying for the last 5-6 years to just keep all these different projects on track. trying to get rid of challenges when people have them, and this is what we've created. So it's radically different in every way to what came before it. So it's DAC technology, it's a complete redesign of our streaming platform, it's a new user interface. Again, because we're carrying high-speed data and control and clock information, we needed to move from AES EBU as an interface, and we developed our own interface for that. So when you put it all together, this is what it is. So we're going to play a track now and do an A/B, and then we can kind of dive a bit deeper into each of the boxes and each of the technologies and what they bring. But yeah, it feels like a life's work, but it's been 5 or 6 long hard years. But I think early on, I could hear what it was capable of. We all could at DCS, and that kind of gives you the confidence or the foolishness to keep going, and just keep trying to build upon it. So that the first time we listened to Varése was 2 prototype boards get wheeled in, and we're feeding them from a Vivaldi upsample, and you're like, shit, there's something here. And then it just starts to build and build and become a system. So yeah, so Emran's going to lead you off. We'll play a track. We'll A/B, but that's the last 5 years journey in a few short words.
Thank you for that, David. So, to be fair, right, that it only makes sense that our greatest rival is within our own range, which is the Vivaldi, and what a great place to begin. So what we're going to play for you initially is this particular track by Nickel Creek on the Vivaldi Apex system. And then we'll play just about a minute and a half, or actually I think just under 2 minutes, get you acclimated to that, and then we'll take just a brief moment to switch the cables over to the Varése system, and volume levels have been matched, and also a mirroring of the settings as well. So this is as close to an A/B as we can get you.
Yeah, we're running through the Relentless 800s. The Magnum Opus and the XV6, obviously.
Yeah,
so yeah,
really proud to be demonstrating with these great partners. Peter, thank you so much for being here. From Wilson as well, just a magnificent product, and we're proud to be able to do this.
Pleasure.
So,
And the source?
this is going to be streaming from Qobuz. Yep.
That's us.
Yeah, there we go. Yeah.
Thank you.
Thank you. All right. And Varése.
So in terms of the units themselves, slightly different architecture. The audio, again, is coming in from Qobuz, the same file, into the network core. So that will do the filtering, the oversampling, sends the data to the left and the right DAC, and then we've got the external master clock. This box you see on the top here is a user interface. This also does the Apple AirPlay, the Google Cast. It has the Bluetooth receiver for the remote control. And that's the system. So really, we you know, like I say, we looked at this on a lot of different levels. So when it came to interface, we wanted to get people to music fast, right? So we were looking at how the streaming services do it, because they're the gold standard, right? How many swipes and clicks before someone gets to great music, whether they be searching for music or whether they're trying to just play music that you know they like or they've favorited. So we wanted same kind of concept where you were able to walk up to the control panel and just get there, just you know, lose yourself in your music. Same with the remote control. So again, you can change the signal path. You can customize the buttons to change phase, to do the things that are important to you. You can control volume. Again, the left and the right DAC are connected with an Actus cable. which is basically 6 twisted pairs, 4 for audio and control and 2 for clock. And that gets us kind of beyond the limitations of AES EBU as a format. You know, if we want to start carrying real high-speed data rates, this gives us a lot of advantages. And again, that was something we tried to design in from the very beginning, was simplicity. You know, in a multi-box digital system, there's a lot of cables at play: AES, BNC, 232, network, USB, all carrying data and audio and control back and forward. So we wanted to make something that was high performance, but also the simplest system that we've ever created. So I think it was one of our retailers over here kept the postcard for the Actus cable, and you know, that's the manual.
That's
it's
the user
that
manual.
simple. You can't get it wrong. So I mean, Andrew, is there anything you want to? Andrew's come along from DCS as well, program manager. So should we give a little talk on the kind of the mono DACs, the architecture, what we got in terms of measure performance, and you know how Actus works? Yeah.
Come on up.
So,
Don't know why.
this is a DCS ring DAC. I think many of you are probably familiar with this. This is the original board from the Vivaldi generation of products. So this is 13 years old now. And on this board, basically the ring DAC works with a unitary weighted current conversion technology. So we have 48 resistors which are fed from a power supply which supplies a voltage. The resistors convert that into current, and then the resistors are controlled by latches which turn them on and off, and the result is summed together to form the analog output. That's how it fundamentally works. So one thing you can say immediately is that one of the governing factors of the sound quality in this kind of architecture is the power supply, because that's what's feeding into the resistors. And that's one of the areas where we've paid a lot of attention in the Varèse to refining the power supply so that the voltage that's being fed, that's driving the resistors, is even more stable, even cleaner. Then we have the magic, the mapper, which decides which, for each digital value, which subset of these resistors is going to be turned on and off. I personally made the mistake of believing that this was the purpose of the mapper was randomizing. It's way cleverer than that. It's not random. It's pseudo-random, because there are rules that govern how this is done. And of course, the minute there are rules, it's no longer random. So the mapper, for instance, if the same resistor were to be used in 2 consecutive samples, the value of the resistor changes imperceptibly over time. And so one of the things is, one of the rules that has to be observed is that one resistor can't be used in 2 consecutive samples. So as the data is passing through the resistors, it's actually at 5-bit resolution and then is oversampled. And that's why we have 48 resistors, so that we can distribute any signal according to this pattern. So in the Varèse architecture, this basic ring DAC architecture has been kind of taken to a new level, a new generation. Instead of 48 current sources per channel, we now have 96. So we've doubled the number of current sources. One of the other things that we've done is the basic ring DAC has become differential. So you can essentially think of it as balanced. So we have 48 current sources which are working with the signal in phase, and we have an inverter which inverts the signal, and 48 of the current sources are working out of phase. So the summed value of the output is always 1, which evens the draw on the power supply, which allows the power supply to perform better and provide cleaner power. It means that the output is doubled, so we get a 6 dB improvement in the signal, but the noise only goes up by 3 dB. So we get a 3 dB improvement in signal to noise ratio, just from the differential architecture. So we've made improvements, many detailed improvements to the power supply that feeds the resistors. We've made the circuit differential. We've now split into mono, which gives very, very good crosstalk figures because they're in completely different chassis. Also allowing the power supplies to perform better because each power supply is only driving the signal for one channel. So many, many small refinements. I'll be in the next room later on for anybody who wants to delve into this in some more detail, but many, many refinements, all of which are essentially aimed at lowering the noise floor relative to what we've had previously, improving the signal level, improving the signal to noise ratio, attendant measurements like linearity, crosstalk, etc. But I think, having done a number of these events around Asia and the tracks that we played, many people, experienced listeners, I've seen them all react within the first second, and often it's even before the first note. They're reacting to the difference in ambience in a recording. The silence sounds different because that's usually buried in the noise floor, and suddenly it's not anymore. And that's one of the biggest differences I personally experience with this system, is just listening to nothing is a completely different experience with this system, and so is everything else.
Yeah, and that's where, that idea of the differential ring DAC is where it all started. And then when you try and build a system around that, you're like, right, how do we synchronize them? And that was where Tomic came in, and we have the patent on that, but that let us keep a left and a right DAC in perfect sync. We were able to change the power supplies. I think we've now got one optimized for digital, one for analog. Then there was the network core. So everything just, it built and it built and it built, and it took a number of years. There was a lot of kind of spin out into existing products and projects. So another kind of innovation in Varèse. So all the mechanicals are machined from a single billet, right? So that means we don't have interpanels and standoffs, and the chassis can act as a heat sink. We can use constrained layer damping. So in addition to that mechanical work, on the electronic side, we use something called a flex rigid PCB. So that was where we were able to get, for example, so this is the Lena DAC. Now this is a single circuit board. This is actually the copper track. So for the first time in our history as a company, we were able to get all of our electronics onto one single PCB. So that gives us better signal integrity, better reliability on the board, less points of failure. And this PCB folds up in and itself and into the chassis. Now we were able, this is 4 points of flex. With Varèse, the core PCB has 9. So that circuit board folds in 9 places around the internal chassis of the unit, which lets us kind of create heat sinks and keep some of the noisier components away from other components. So, Varèse was really the test bed for a lot of innovation that made its way into existing products. So Apex was, the output stage is the same in the Apex ring DAC as what's in the left and the right DAC here. So there was all this kind of inspiration and innovation coming out of this project, and this is the final result. So yeah, I tend to talk stream of consciousness here, so we'll play some more music, but yeah, kind of get excited about it. Ultimately about what happens between these speakers, and then in that space in front of you. And again, that was part of the reason why we got rid of all the visual displays. We put them into one box. so that ultimately it's about the music, you know, and the system should just disappear. So just one other little thing, maybe, Andrew, do you want to talk a little bit? So again, as well as simplicity, the Varèse DACs have a pair of balanced outs and a pair of single-ended outs, so you can run, you know, an amp and a sub from each channel. The Varèse core, again, we designed that to be modular, so, you know, thinking about where audio is going and what people want from the system. So we have a module that we'll start shipping next month, which has AES, USB, RCA ins, a word clock out, and a 232 out, which can act as a 12-volt trigger. We're working on an HDMI module, and we've got some other ideas for other functionality. So that lets us expand the system, and it's just by inserting a module. So the first one is the I/O that will be available in February. Theoretically, in the future, there's different things. There's 8 Actus ports on the back of the Varèse, so we could do some clever things as well with different frequency ranges. So there's a lot of headroom and a lot of processing power in there, and now it's about, we want to get it out there, get people using it, and see where it goes. But the other thing on the Actus, so Andrew explained a bit about it, but this is certified up to 100 meters now. So again, that gives you a lot of flexibility in terms of the system, and where it's located and how it's configured.
Unequal length's not a problem.
Yeah.
I mean, you figure you can run 330 some odd feet. You know, you could have DACs on left and right by the speakers. You could have the core and the user interface elsewhere in the system. No requirement in terms of you know, equivalent lengths or any of those limitations.
Yeah, the master clock is optional. So the only cable you have to get right is from the clock output on the clock to the clock input on the Varèse core. But the Varèse system would run as a system without a clock in play. Everything else is just, you know, connect it up.
Without a master clock. There's clocks in both the DACs.
Yeah. But yeah, I think the intrinsic jitter performance is superior on a Varèse minus an external master clock to a Vivaldi with. So again, we made some big gains there. But do you want to explain a little bit about what this is doing, and maybe pass it around actually?
Yeah, absolutely. So one of the things I've learned, sort of fun things I've learned about the Varèse project is, as we realised directions we wanted to take technically, we started creating new challenges that had to be solved. So the project kind of mushroomed. I explained how, you know, we improved the power supplies, went differential, went mono. Well, once you have digital analog conversion taking place in multiple places for the same sample, you create a potential problem for yourself. How do you know that, you know, sample number 24 is being converted at exactly the same point? You know, we are not the first manufacturer to release a product with mono DACs. How do the other guys know that their 2 channels are converting the same sample at exactly the same time? Well, to the best of my knowledge, they don't. They rely on the fact that the cables are the same length, the signal is traveling at the same speed, and therefore they should be converted at roughly the same time. Any of you who know Chris Hales will know that that's not good enough for Chris. He wants to know that those samples are being converted at exactly the same time, how to achieve that. And I believe that was where Actus started, was as part of the solution to that problem. How do we keep the 2 channels exactly in synchronization? So I don't know how much detail you want me to go into, David, so stop me if I start descending down the rabbit hole. But the clock signal, as in our products at least, is a square wave, known as TTL. So as the voltage goes up, is up for a while, and then it goes down. The timing reference is the leading edge of the square wave. The trailing edge is just recovery. It's just sending it down again so it can go back up. So the leading edge is the critical one from a timing perspective. What Chris and Andy, I know exactly which one of them invented, was this idea whereby, okay, if we modulate the trailing edge, which is just a recovery part of the wave, we can modulate it in a way that if we bring the trailing edge closer, we shorten a pulse, then we can use that to represent a symbol. And if we delay the trailing edge by, say, a quarter wavelength, we can have that represent a different symbol. So basically, by modulating the trailing edge of one pulse, we can encode a binary 0 or a binary 1. And we can have a receiver at the other end that can retrieve that. So essentially, this formed the basis of a patent, which is we've called Tomics, which is a way of sending control signals embedded within the clock. So the Varèse master clock, if present in the system, as David said, it's optional. The DACs each have their own clocks. The Varèse clock, similarly to the Vivaldi clock, has two subsystems, so it can produce two sampling rate families. You can have one on 44 one family, one on 48 family. It's sending those timing references to the core. It's connected only to the core, and the core distributes that timing reference to all the other units that need it. In this case, the left and right mono DACs, which have their own clocks in. So basically, this modulation of the trailing edge of the clock signal that's sent from the core to the mono DACs is used to send information about when that signal was sent from the core, which allows each mono DAC to calculate the amount, the delay, and synchronize themselves with that master signal, which ensures that the same sample is converted in left and right channels at exactly the same instant. So an entire new invention, a new patent that was necessary to solve a challenge or a problem that was created by the decision to move to mono DACs, which was necessitated by the need or the discovery that that was a way that we could dramatically improve the signal to noise ratio of the products. Similarly, so that's Tomics. This is an Actus cable, a little bit closer up. As David said, 6 twisted pairs of conductors. Yeah, so this is what Jim is holding here. This is just a magnified view. So if we start up here, these are 4 twisted pairs of conductors, asynchronous, high bandwidth. Does that remind anyone of anything? 4 twisted pairs of asynchronous, high bandwidth communication. John's nodding. Exactly. So this is essentially based on Ethernet technology, so it's capable of transmitting the same bandwidth. We use this to send audio and control information between the units, which means that the system can be configured centrally through the user interface. That configuration information can be sent around the rest of the system. In the previous generation, you had to set the settings on each of them.
And that also gets us, AES, EBU has that, 4 megabits a second kind of limitation. So when you've got a multi-box system, this gets us higher sample rates.
Way beyond that.
And yeah, way beyond it and into the future. So,
So that's this bit. Then we have 2 more twisted pairs. These are for the Tomics, the 2 Tomic signals for each family. So these are essentially just sending the square waves with the modulated control function that is part of Tomics. And the reason I sort of drew this expanded view is you can see that these are grouped separately. So you have your grouping of 4 twisted pairs for audio and control here, and then moved away from them and individually shielded within the cable, you have your 2 clock lines which are sending timing and control information. So this means that this cable, you basically, for each system of n boxes, you need n-1 cables, identical cables, and that sends all the information. It's almost like an umbilical. It sends all the information between the units. And this was our way of achieving all these diverse technical objectives but at the same time providing a cabling system that is almost idiot-proof. Literally, you plug it in to each unit at either end. It's, for anybody who's plugged together a Vivaldi stack, it's not entirely idiot-proof. Let's leave it there. I have a Vivaldi at home, and I've done it wrong many times. So this was a solution both to technical problems that we've overcome with Tomics, with Actus, but also to the usability, making it easier for the customer, bringing them closer to their music. Probably important to say, because I think some people have sort of misunderstood, DCS is getting into the cable business, etc. They've seen there's money to be made, etc. It's absolutely not. We've sent this to our cable company partners, the LEMO connectors that are used. This is a custom LEMO that we have designed, or we've specified for LEMO. We've sent this to our cable partners. We will certify third-party Actus cables. We're not trying to close out, make this a proprietary system or shut anybody else out. This is a solution to a technical and a usability problem, which enables the system to perform in the way it does.
Well, let's switch genres. Let's go to something of a classical variety. We're back on the Vivaldi Apex. We're going to play a little Copland for you, and then we'll switch over to Varèse. Fanfare for the common man. All right, and Varèse.
And make everything in the UK. This is like 40 years of learning and trials and tribulations applied in this project. We've tripled in size in the last 10 years, but there's not many companies, I think, now that do all their own software, all their own hardware. We build our own test systems. We had to design our own interface, and then we had to build test systems to test that. But this is what it's about, that experience, and when you hear it and you get a feel for it, you want to keep going and keep pushing it and seeing where it can take you. And yeah, I'm super proud of the team. I think they've done a hell of a job.
What changes did you make in the analog domain and the output? I mean, because that's part of this whole process.
That's a great question.
Yeah, the analog domain changes were primarily what made its way into Apex. Apex was a redesign of the analog stage. So it was like the summon stage, the filtering. With Varèse, a Vivaldi has 2 transformers, but they're identical. With Varèse, we've optimized 1 transformer for analog, 1 for digital. So there's a lot of kind of like marginal gains and incremental improvements, and then there was the real big, step changes in technology and interface. So yeah, like I say, it's just been a blank sheet really, but it started with the mono DACS, and then everything just built from there to turn it into the system that it is. So we never really, you're not really looking at like a market or a customer, or like you start with a spec. It's really, I think the way we've always done it is, right guys, here's the challenge, where do we think we can improve, and they'll go away and kick something back over and we'll try that, listen to that, what do you think? Andy's favourite line is like, it will never work. And then eventually I'll say to him, look, tell me, come on, is it going to maybe work? And he's like, sometimes if we can get from it will never work to maybe, we know we're in a good place. So there was a lot of, well, we're not sure for a long time on this, but.
It's a very holistic approach, but the thing that I think is so uncommon and refreshing though with Varése, right, is that oftentimes, especially at the flagship level, that you introduce with performance comes complexity, right, which makes the operation somewhat arduous at times. And with this, I can honestly say Varése is the most simple and easy to operate and intuitive model that we currently make.
Easy to configure.
It really is. Yeah. So the performance is accessible. You can have all the performance in the world, but if it's not accessible and if it's not intuitive, then what a waste, right? And with Varése, we accomplish not only tremendous new levels of performance, but also the ability to access it so much more easily.
So the anxiety factor is gone.
Yeah, absolutely.
There was an anxiety factor before when you were switching something and you had trouble getting back to it.
Yeah, exactly.
That's
so
right.
now, for example, so this signal path button here, right, it will come with pre-configured, recommended signal paths. So there's a PCM stage, there's a DSD, but you can program your own, and then you can just toggle through. You can get back to where you were. This is play, pause, this will change. So we really try to think about simplicity at every stage, from installation to configuration to using it. Can you walk up to it and in a couple of swipes get to music and then sit down and everything disappears again? So the mapper, and so we if it's PCM, we keep it PCM. If it's DSD, we keep it DSD, or you can convert PCM to DSD. So you see, we have them here. So you can create your own and save them, or you can go with the pre-configured ones, but pressing the signal path button will toggle through. So again, we've made that much simpler. So you can just set.
Default is plug and play.
Yeah,
exactly.
So for instance, under here you'll see that we have current presets, right? So DSD, PCM or DSD, measured, right? So taking kind of the mystique out of which combination is going to give me that sound that I'm looking for, right? That you can do that. But then, being able to very quickly and easily, jump in here and be able to manipulate things that are unique to specific signal paths. So for instance, DSD, if I just want to control the filters that are related to DSD, likewise with PCM, same thing, right? My ability, I can change mappers, just a lot more simple and intuitive, easier to access.